All right, guys, so this time we are going to be using the infinite formula. I know we're using the infinite formula because I see infinity at the top there. Also, the 3 dots mean that it continues forever. I don't have the infinite formula on my screen, so let me just recopy it real quick. That is going to be a sub 1 and then 1 minus r. So for problem 1, the way that we're going to find this is we are going to find a sub 1 first, just like we do with finite. So a sub 1, remember it starts at 0, so n is going to be 0. This is going to be 2/3 raised to the 0 power. So again, your a value for our first term is going to be what? What is anything to the 0 power? That is a 1 right there, but yes, he's right because there's a 2 right there. So when we multiply by 2, a sub 1 is going to be 2, which means on the top of this fraction bar is just a 2. What's underneath the fraction bar? What's 1 minus 2/3, guys? 1/3. And again, these are a little bit easier than the finite. So on your calculator, what's 2 divided by 1/3? That's right. Box that in because that is the right answer.
How is the sum of infinite numbers 6?
Because what's happening right here, the higher you raise that to an exponent, it's a fraction, the smaller the number is going to get.
So it would be about 6.
If you could add up all the infinite numbers, it would add up to 6.
It would be like 5.99999.
Guys, we're going to find a sub 1. Remember, a sub 1 is starting at 0, so the n is going to be 0. What's the a sub 1 for number 5? So it's going to be 2 times negative 2/3 to the 0 power. What is that? That is going to give us another value of just 2. A sub 1 is 2. So when I go to draw my little setup here, it's still going to be 2 on top. But guys, remember your common ratio is negative. So when we do 1 minus a negative 2/3, we're going to end up adding that. So we're going to have 2 over 5/3. So when we do 2 divided by 5/3 on the calculator, we're going to get our sum. 1.2.
I just have one.
You check your calculator.
Oh, it's 1 minus negative 2.
All right, guys, let's go ahead and take a look at problem 6. So for problem 6, we actually need to figure out the pattern here. So in order to figure out the pattern, remember to find the common ratio. You look at a term and you divide by the previous term. So the common ratio is going to be 6 divided by 9, which is 2/3. And then remember, our little formula is the first term, which is 9, raised to the 2/3, and it's going to be n minus 1. That would be the geometric formula for that. However, remember, we're just going to add the infinity series on this, so we're going to be using this formula up here. A sub 1 is already given to us. It's right there at 9. So our first term is on top, and remember, underneath is 1 minus the common ratio. The common ratio is 2/3, so 1 minus 2/3 is 1/3. You always do 1 minus the common ratio. It's not, that's a mark on my paper. So the sum is going to be, when you type that in on your calculator, you should get 27. 9 divided by 1/3 is 27. All right, let's look at this next one. First of all, guys, what do you notice about these signs? What's happening with these signs?
Switching.
The signs are alternating.
Yeah.
When the signs are alternating, remember your R is negative. However, we're not going to be able to add this up because the R value is going to be greater than 1. Let me show you guys. I'm going to look at the second term here. The second term is 25 over 6. Now I'm going to divide it by the previous term, which is a negative 125 over 36. Y'all, I'm just going to use my fraction rules. I'm going to keep, change, flip. So this is 25 over 6 times a negative 36 over 125. Lots of cross-canceling that's going to happen, y'all. 6 goes into itself once. 6 goes into negative 36, negative 6 times. 25 goes into itself once. 25 goes into 125 5 times. So this ends up being negative 6/5, and it's going to be impossible because the absolute value of my common ratio is greater than 1. So let's write no sum. The answer is no.